here we are going to look at bar charts. All right, so the table below shows the heights in centimeters of students in a school. So these are the names of the students and these are the heights, right? On graph paper, draw the bar chart to represent the data given. A bar chart is not a histogram where the bars are joined, the bars are separated, and the separation of the bars, each bar must be the same width. So each rectangular bar itself must be the same with all of them. So Jameson, Thompson, Johnson, Lenson, Simpson, all of those bars must have the same width. And the spaces between the bars must have the same width as well. So they said 2 cm to represent one student on the x-axis. So since we don't have any negative numbers, we are using the border of the graph page. 2 centimeters to represent one student on the x. 1 x. And 1 centimeter to represent 10 centimeters on the y-axis. All right, so here we see the highest number is 145, so I'll go up to 150. All right, so 150 is good enough. Even if you put 160, doesn't matter. So that is heights in centimeters, height in cm, and here will be names. All right. So the first one, we're going up to 125. Jameson, we're going up to 125. All right. So it's only 2 centimeters, and I'll skip 1 centimeter. So here's Jameson. So that's Jameson. Next one is Thompson, 130. So Thompson is 130. So this is Thompson. Right. Johnson is 100. Johnson is 100. Lenson is 145. Says Lenson. And Simpson is 125. All right. So these are the bars. So these are the rectangular bars. So each rectangular bar has the same width, right? All the names has the same width, and the spacing in between the bars has the same width as well. Very important. All right, so let's look at the following questions. All right, so determine the range in height of the student. So the range is the highest number minus the lowest number. So the largest number is 145, smallest number is 100. So the answer is 45. That's the range. Trying to have my handwriting. Okay. Part C1, which is the tallest student? The tallest student is Lenson, right? So Lenson is, so they're asking, how was that information shown on the bar chart? Right? So when you look at the bar chart, Lenson, okay, right? Lenson is the tallest, right? And to show it on the bar chart, it is the tallest rectangular bar, or it's the highest rectangular bar. So keep it simple. So, all right. So they said between which two students was there the greatest change in height? So when you look at this, you see in Thompson and Johnson, right? Thompson and Johnson, all right. But when you look at Johnson and Lenson, when you look at Johnson and Lenson, that's the greatest change in height, right? So the greatest change in height is between Johnson and Lenson, right? Now the next question, how was this information shown on the bar chart? So when you look at the bar chart, we can see the difference in height of the rectangular bars are significant, are most significant, right? So the difference in height between this and this is most significant. You could further say 145 minus 100 is a 45 centimeter difference. So the difference is most significant, right? You can also mention, and the difference in height is 45 centimeters. So when you look here, right, there's 100, this is 145, right? So the difference in height is more significant, 45 centimeters. The last one, they said give one reason why the bar chart is unsuitable for predicting the height of the next student. So when you look here, we see these are the heights. So if you think, okay, what is the next student? We cannot tell because the bar chart does not predict heights, right? The bar chart doesn't predict height. The bar chart just states what the data represents, right? So that's all we put in. The bar chart. So the bar chart does not predict heights, but states what the data represents, right? So the data represent Jameson is 125 centimeters tall. So Thompson 130, Johnson 100, Lenson 145, Simpson 125. So you're just stating what the data represents. All right. So that's it for bar charts.